Hello, and welcome to today's conversation, Sense, Perceive, Locate, How Robots Can Find Themselves, presented by Here Technologies. I'm Bennett Richardson, General Manager of Protocol. Thank you for joining us. At Protocol, we aim to arm you as decision makers in technology, business, and policy with actionable news and analysis that can help you do your job. Robots and autonomous vehicles need to know where they are in order to function properly and choose where to go next. To achieve that, those robots, from warehouse helpers to autonomous semi-trucks, must use onboard sensor data and compare it to constantly changing 3D maps of the world. But the sensors need to capture the right data, those maps need to be updated regularly, and those onboard computers need to be able to crunch all those numbers. Today, we'll explore how all this happens thanks to advances in location intelligence, cellular data networks, and mobile computing, as well as what it takes to make it possible. Hope you'll join the conversation by tweeting your questions with hashtag Protocol Enterprise. And if you're not already subscribed, don't forget to sign up for Protocol's family of newsletters at protocol.com/newsletters. To kick things off, I'd like to welcome Edzard Overbeek, CEO of Here Technologies. Here is a location data and technology platform that moves people, businesses, and cities forward. And Here location services are used by enterprises across the globe. Mr. Overbeek brings to Here a unique mix of technology and sales experience, having joined Here from Cisco, where he was a strategic advisor and responsible for the global services organization with more than 12 billion in revenue and 15,000 employees. Welcome, Edzard.
Thank you, Bennett. Thanks for having me.
Of course. So, Edzard, this market seems to be shifting really quickly, with businesses wanting HD and 3D maps, as well as digital twins across all sorts of industries. Tell us, why now? What is happening that makes today's conversation so timely?
You know, Bennett, it's almost like a perfect storm coming together. If you take a look at this space, probably 2 decades ago, many of the companies that were in the mapping industry figured out how to combine, road geometry with basically static data sets. And that has been driving a lot of good business in many use cases that we use actually nowadays in navigation in the car, in navigation on mobile phones. I think about a decade ago, we started to move into location intelligence, and we started to add real-time data sets towards that, connecting to probe data sets, sensor data from cars, etc. But what is happening almost 5 years ago now is pretty big, right? We started to talk about an autonomous world. We started to think through what it would mean to have autonomous cars, autonomous drones. If we go into other robotics into the world, how would that start to create an opportunity to move from location intelligence to spatial intelligence? How can you start to create a near real-time digital representation of the world where you can look around corners, where you can see through buildings, where you can start to orchestrate things at a scale that has never been seen before? And I think what is happening with the rollout of 5G that now creates sub 1 to 2 milliseconds latency in cell environments, or the combination of e-commerce that has driven through the roof, as you've seen, because of COVID. How do we optimize supply chains and make sure that the user experience with location data gets into a very different way? Those are just some of the market forces that we are seeing that creates a fundamental shift from location intelligence to spatial intelligence.
Yeah, I would love for you to expand on that a little bit. This shift from what we would traditionally think of as location intelligence and location data into this more comprehensive spatial intelligence space. What does that mean both for the business and for the technology that you all are developing?
Let me start with the later part, the technology piece. What you need to have is a platform approach that basically can ingest any type of location data at scale. And you need to have the capabilities to do change detection at the edge, so you don't make the mistake to put everything into your database and therefore just have massive storage cost and compute cost. And that's exactly where I think Here Technologies have been investing in for the last 3 to 4 years. We have now a capability where we can bring in 2-dimension, 3-dimension, static, real-time, near real-time, dynamic data sets. We can move from location to spatial data sets. We can offer our customers to bring in their own data sets and build ground truth into this database going forward. If you then start to think about business opportunities, I would argue if you bring spatial intelligence towards almost any use case that is out there, it will change. Traditional ways of looking at a supply chain end to end is basically not achieved right now. If you bring asset management and tracking towards that, you can start to take a look at a certain component, understand when it's being docked on a ship, understand weather conditions, how the ship is entering the port, start to pre-utilize the port with the load moving into train or into road carriage, then starting to move into distribution center, and in the end, move into last mile. The combination of that view is extremely powerful. And that's something that spatial intelligence is starting to solve at scale.
No, that's fascinating. And thinking about that sort of spatial supply chain across the entire chain there is really interesting. I mean, tell us more about Here Technologies, like across that extremely complex system. What role do you all play in the ecosystem?
You know, Here has been 5 years now as an independent company. We came out of Nokia. It was bought by 3 German car OEMs, Daimler, BMW, and Volkswagen Group, because they realized that for autonomous cars, you need high definition maps. And you don't just need maps, you need a systematic approach where anonymized data sets from the sensor cluster of the car will start to create near real-time mapping capabilities on top of all the other sensors that are in the car. And it's funny because I think 5 years ago, the jury was still out whether maps would be important or not. And I always say, you know, it's not maps that we deliver, right? We deliver a logical instruction set to have vehicles or things take decisions, right? We're one of those important sensors that are coming in. And the more you think about it, that was the start of the journey. But very quickly, we also said, okay, that is cool, but what if we would start to create this spatial intelligence? What if we would create a 3-dimensional representation of the world, not just on the road network, but moving into buildings with indoor mapping solutions, with venue solutions, and how we can start to move with high precision positioning to start serving other industries. We just announced today, as you've seen, a very strategic deal with Lyft, where we're using the search and the POIs with Lyft on top of their capabilities and are facilitating 1 million users of Lyft to start using the data that we can offer and create a very different experience for Lyft going forward. So those are just a couple of examples that we have been investing in. Over the last 3-4 years, we spent significant amounts to build the platform, to start to move into these software applications. And I think it's time for us to start talking about it, which is a fantastic opportunity here today with you.
No, that's really exciting, and congrats on the Lyft news.
Thank you.
That's big. You know, I want to pick up on something there. You mentioned anonymized data sets. Obviously, when we talk about partnerships, one of the things that comes to mind is privacy, right? And location data, especially sensitive, both in terms of traditional data privacy, as well as obviously like user consent management. You know, you all are a European-based company. How does Here view privacy, both today and looking into where this is all going?
Yeah, and it's, I think, one of the most fundamental questions, right, that we're solving. And you know, we're a bit lucky because coming out of Nokia and that company, we had privacy always at the very core of how we implement products. Very simple things that we ask the user exactly, you know, what we would like to use and why we're using it and how we're using it is just one way. We have launched a service called anonymization, where we're using our own capabilities for customers that feel insecure whether they have anonymized the data well enough. We guarantee that we do that. Or even consent management, right? One of the examples I use in some of my conversations is when GDPR got implemented, it was almost a non-event for us, right? We were already GDPR compliant. We operated that way, and we made sure that every single time both business and consumers would use us, that we respect that privacy. I think as an industry leader, it is extremely important to continue doing that. And you will hear us talk much more about it. You will see new products being announced in that space that give full transparency to businesses and consumers of what it is that we could do with the data and how we can provide better services for you, but you will determine that and nobody else for you.
No, that's great to hear, and that'll obviously be a key challenge, you know, for the industry moving forward. I mean, location and spatial intelligence, plays a key role, obviously not just in, the obvious use cases like autonomous vehicles, but also in smart cities, Industry 4.0, with, safety being crucial across all of these. Before we head over to the panel, would love just, one kind of parting thought from you. What are some of the other key challenges that the industry needs to overcome to achieve that future?
Yeah, we believe that together we can start to create something very powerful. And part of the reason why we have created our location and spatial intelligence platform is we want to basically be a safe zone, like a Switzerland for location data. But that also creates a lot of opportunity for others to start building this ecosystem together. We think it's very arrogant that there's companies out there that claim to do it all by themselves. We don't want that. We would like to build this ecosystem, understand what data sets are applicable. How can we strengthen that together in a marketplace where you control your data, enriched with location capabilities, and start to provide the insights and provide new ways to build businesses or provide better insights for smart cities or for mayors as they're trying to solve the challenges with the cars in cities and how to build cities of the future. There's many opportunities out there. So we believe that the biggest challenge we have is not to participate together. And we're inviting everyone to be a part of that, because I think together we can create something quite spectacular going forward.
Well, it's exciting to hear. Thank you so much for those great insights, Edzard, for joining us today and for your partnership on this important topic.
Absolutely, Bennett. Thank you.
Great. Thank you. Now on to the panel. I'm excited to introduce Protocol Managing Editor Jamie Condliffe, who will moderate today's conversation. Jamie, take it away.
Thanks, Bennett, and welcome to today's event. I'm Jamie Condliffe, the Managing Editor of Protocol, and we're here to discuss the seemingly simple but actually incredibly complex topic of localization in autonomous cars and vehicles. This is the idea of getting robots, whether they're cars or trucks or delivery devices, to look at the world around them, process what they see, and understand where they are. That's obviously incredibly important for all kinds of reasons, from route planning to knowing where a passenger needs to be picked up from, to being in the correct place on a road. Humans take at least some of that for granted because we have an intuitive understanding of the world around us. But machines see the world differently to humans, and that's what we'll be discussing today. We have a great group of people here to talk through that topic. And to cut down on the time you need to hear my voice for, I'm going to ask each of the panelists in turn to introduce themselves as they appear on my screen. So, first, Ashu.
Hi, I'm Ashu Rege. I'm the SVP of software at Zoox, which is a company delivering autonomous mobility as a service to the ground-up vehicle. We are part of Amazon. We got acquired a year ago, almost, and happy to continue this journey.
Thanks, Ashu. Next up is Alejandro.
My name is Alejandro. So I'm the VP at Qualcomm for ADAS. Basically, I'm working in the field of ADAS since many years, also leading the development at Volkswagen, BMW, before I joined Qualcomm recently. So I'm happy to share my experiences here.
That was great. Thanks, Alejandro. And next up, let's move to Christoph.
Yeah, hi everyone. My name is Christoph Schroeder. I'm VP Software at Luminar Technologies. Luminar Technologies is a company that produces long-range LiDAR sensors. You actually see an image of one of our sensors, a Hydra sensors in my background. I lead software at Luminar, and we develop LiDAR sensors. We move into full stack solutions. We work on proactive safety, for example, to really make sure that we deliver value today and save lives today without having to wait for robotaxis being deployed everywhere.
That's great. Thanks, Christoph. And we do have one more panelist, Jyoti Sharma from Verizon, who is having a few technical difficulties, and hopefully she will join us as soon as she's able to get online. I thought we could kick things off with a very general question that I think should springboard us into a fairly freewheeling conversation. And Ashu, we're going to start with you. And so this seems simple, but I think it might be more complex than it first appears at first blush. What is the need for precise localization in an autonomous vehicle?
So localization tells the AV where it is. which of course has to be with respect to some prior information, such as maps. In the robotaxi world, we are operating in geofences that are known ahead of time. So at Zoox, what we have done is develop a highly sophisticated LiDAR-based mapping and localization technology that's enhanced by other modalities. And this allows Zoox vehicles to localize to a very high degree of accuracy. So why do we need localization, and why do we need precise localization? So if you look at a driving scenario, you have three kinds of information you care about, roughly speaking. The static world geometry, for example, roads, curbs, sidewalks, and buildings. Semantic information like lane markings and speed limits, etc. And then the third part is the location and state of the various dynamic entities like pedestrians and other vehicles. So an HD map that we create, for example, typically stores the first two as a prior. Now, driving is very peculiar in that you're generally required to stay in your lane, unless you're changing lanes, of course. And so that's very important to understand where you are with respect to that semantic information. And this is what makes the problem particularly challenging, because if you believe you are at point A, but you're really offset by a certain amount, if your AV believes that, you're going to drive in a completely different way with respect to all the other entities, in particular, for example, staying in lane versus straddling the lane, which can create an unsafe situation. And then, of course, with respect to other landmarks like dividers and so on.
Sure. And you mentioned this, Ashu, in passing, just saying that Zoox has developed a suite of kind of LiDAR sensing to help with localization. But Christoph, maybe you have some thoughts on this. How important is it for different sensing modalities to play into this localization problem?
I mean, it definitely is important to have different sensing modalities, because all of them have their function insufficiencies, right? Not everything works everywhere the same. Everything has their own strengths. But specifically in robotaxi applications, but also now more and more in ADAS applications, you see that people move away from the traditional kind of lead sensors, which were camera and radar, to LiDARs. Actually, they move to LiDARs as the lead sensor, because the fidelity of the data, the precision of the data, the accuracy that you get is just so much higher, right? That's why Ashu mentioned also that they developed the Zoox LiDAR-based focused localization. I think most companies actually are moving in that direction, and it's really all about precision, right? Especially when you look at the applications that we have in mind these days. It's all about precision. You need to react to objects in the map properly, landmarks that are in there. And for that to happen, you need a certain level of precision, centimeter level precision, and the sensing technologies that are available need to really support that in all environments and all conditions, independent of whether it's raining, snowing, or whatever is going on around the vehicle.
Sure. I mean, so you're talking about a lot of different data streams and a lot of different data points there, right? And that suddenly becomes a very big computational problem. So I thought, Alejandro, maybe you had some thoughts on this. Like, how easy is it to bring together high fidelity LiDAR sensing and say 10 cameras and 4 radar sensors and process that in a car in real time?
So I think if we look into the past, I mean, compute power was always a limiting factor, right? So there was much more the engineer could think of doing than the hardware was able to support, right? I think we are at a point now where if you design the hardware in the right way, that you design it so that it fulfills the requirements of the software and what is needed, I think there is enough computing power to process data and manage the amount of information. Looking at the discussion that we just had, I would like to add one perspective into the discussion. So I think we have to be very sharp when we talk about autonomy, because I think there are two kinds of autonomy, right? One kind is a robotaxi application where I think the business case is different, the technology that we can put into it is different. This is a much more controlled environment. And if we look into our customer cars, right, there's only so much hardware that a customer can afford in the car, right? So I think we will have a much more camera-based localization in consumer cars, while in robotaxis, we will use the whole phalanx of sensors that are available to bring it to a much higher level of accuracy.
And what kind of limits does that kind of budget limitation put on the fidelity of localization? I think maybe all of you could be able to chime in here. Like, operating in a regime where you're just using cameras is obviously quite different to using LiDAR as well. What's the difference in, like, maybe we're thinking about difference in centimeters or inches, or are we talking yards, or like, I'm kind of interested.
I think it depends on the use case that you're addressing, right? So I think in today's level 2 systems, for example, an accuracy of over a meter is something that you can live with because the driver is still in charge, right? So he will always correct it. It's more a supporting system than a real automated system. When you get into the field of level 3, level 4, where it's automated and the car takes over the responsibility, you will also see that if you're on a highway, for example, you need that high accuracies as in downtowns, for example. So that on the highway, it's important to know where you are, what's the curvature ahead of you, and you don't want to miss an exit, right? But if you're in urban scenarios, I mean, it's relevant where the curb is, where the pole is, and where the whole furniture is, for example, right? And in these scenarios, we have to get down to under 10 centimeters accuracy, even in the centimeter range.
An interesting thing that just occurs to me is how easy or hard is it to localize in those different environments anyway? So I assume on a highway, in highway driving, there are fewer waymarks to actually latch onto to work out exactly where you are, but maybe it's less important. So is there a trade-off there? Maybe Christoph, you can speak to that.
I mean, I wouldn't say something is easier or more difficult. I think it's just different, right? In urban environments, yeah. I mean, in urban environments, you have very dense scenes. You have a lot of landmarks, a lot of things that you can use to localize, right? So especially with dense approaches, you have a lot of redundancy around you and can achieve very high accuracy with your approach. On an highway, like a very deserty-like highway, let's think Road 66 or something like that, you don't have any landmarks, right? There are lane markings, there are maybe traffic signs once in a while, but you still need to know where you are because you want to react to things that are in the environment that are going on around you, right? Like landmarks, like signs, exits, and so on. So it's just a different challenge, and you actually do need different approaches when you want to solve for both of them at the same time. It's not. I don't think there is a one-fits-all solution that would be able to solve for both of them. Maybe to the point that you guys made earlier regarding level 2 cars and which technology they need to localize themselves. I would actually agree. I think localization will not be the driver, at least in level 2 cars, will not be the driver to introduce LiDAR sensors, for example, in a broad scale across the board. The driver is a different one. The driver is really being able to understand what is going on around you, being able to really detect precisely what is in front of you, and then acting and reacting on that, right? And building safe vehicles, the safest vehicle possible. That's the driver why a lot of companies actually are thinking about standardizing LiDAR sensors on production vehicles, like with Volvo, for example. They just recently announced that they will be standardizing Luminar technologies on their battery electric vehicles. And that's the driver. And then as a next step, when you have those sensors, then you can leverage them and use them to localize in all the different environments. But it's not the other way around.
Got it. Yeah, that's a good point. I'm just going to take a moment out of questions and answers to introduce Jyoti. And I thought, Jyoti, maybe you could introduce yourself because you didn't manage to go at the start due to technical difficulties.
Yeah.
So
Hi, Jamie. I hope you can hear me. Hopefully we've resolved the technical difficulties. I'm Jyoti Sharma from Verizon, and I've been focused in the past several years on defining Verizon's connected and autonomous vehicle strategy, technology strategy in particular. So today I'll talk about the 3 main technologies that we brought to the table in the last couple of years with 5G, multi-access edge computing, which is bringing compute and storage resources closer to the edge of the device, as well as hyper-precise location services that allows centimeter level accuracy. So all these three technologies will enable the autonomous vehicles to exactly know where they are. And we talked about spatial intelligence earlier. I would add one more dimension to that is timely information is critical here, because the information gets stale and within a few milliseconds, the scene changes on the road. So as human beings, we know where we are located. We are used to the map applications, which are two-dimensional maps today in our vehicle over a mobile device. But now with these enhanced technologies, we can predict exactly within centimeter level of accuracy where that bicyclist is or a vulnerable road user is, and communicate that information over the 5G network through our MEC platforms and inform the other users on the road within centimeter level accuracy in a timely fashion with a localized cloud rather than distributed cloud rather than a centralized cloud architecture. Because if I'm driving in New York City, I don't care what's going on in Miami. I really care about what's going on in my city.
That's great. And that brings me to another question, which is, I hope we could kind of move on for a moment from the idea of onboard sensors to what other kind of data sources can even be used to help localize. And I think, Jyoti, you've touched on a few ideas there, but I wondered if everybody could try and speak to that and what kinds of extra data might be useful. I don't know whether, Ashu, you have some ideas on that.
Yeah, so obviously this typical stack that's on a AV system has GPS, which is kind of the basic starting point where you kind of start figuring out where you are. But the reality also of an AV system is a fully autonomous system is that it needs to be fully autonomous. So it cannot just rely solely on some of these technologies, which are great, like 5G. But it has to have a sort of all of the above approach in order to continue making, being safe and making forward progress. So in a typical stack, you also use sensors like wheel sensors to locally know. Once you know where you're at a certain point, you can start locally estimating how far you have moved. And so use what's called the IMU, the inertial motion unit. And these all allow you to integrate the distance traveled over a certain period of time. Then other technologies that people have proposed are beacon technologies, for example, using traffic light poles, street lamp poles. All of these are great, but again, it is very important to understand two things. One is the AV system has to deal with long tail events, which are relatively low probability events, but which can have really serious negative consequences. And so it has to have a system that can run on its own to the largest possible extent. So while leveraging all of these assistive technologies.
And how easy is it to kind of bring all of that together? I mean, that's a lot of, it feels like we're talking about more and more and more data streams that we need to try and bring together and make sense of. What approaches do you use to combine them for this task? And like, how easy is it?
But certainly, anybody who's done any kind of complex system, bringing hardware and software and cloud together, will tell you that integration is probably the hardest problem there is in making sure everything works. It's the least glamorous of all the problems, but it is really the challenge that almost every system faces. And so, yeah, how do you bring all this together? How do you make sure the standards that, for example, if you're communicating with services provided by other companies, what kind of reliability do you have? All of those things absolutely start factoring in. At Zoox, we are intently focused on putting out a product. And so we have to look into things like redundancy, for example. Do we use one service provider or two? In both redundancy at the vehicle level, on the hardware, as well as services themselves. And so all of those factors have to be built into the system ahead of time if you want to, seriously launch a product.
And Alejandro, thinking about how we can use different pieces of data, maybe for advanced for driver assistance systems rather than for full autonomy level 4, whatever. Are there different bits of data that a car can take on board and use for those systems without having to use fancy LiDAR data?
So I think even level 2 regular ADAS systems today, if you look, they're pushing technology further and further, and you have different levels of level 2, right? So on the high end, you find LiDAR sensors in those cars, while in the lower end, you will probably find a camera and a radar as a safety standard equipment in the car, right? I think all of those sensors, first, they can be used first to create more precise detection, increase accuracy. And it is a way, the question on how are you combining these information. I think what usual in industry today is that every sensor comes with a detection module, and you fuse on a detection, on an object level, right? So fusing detected cars, for example, right? I think the future will be much more raw data based, because the moment you extract an information out of a camera, maybe you're extracting wrong information, because the pixel that you threw away could help to understand better a reflection on a radar. So we will go deeper in the system architecture and work more with raw data, and then come to a conclusion on what is going around the car.
Okay, great. I think I'm gonna try and come back to one of those points in a second, but I would like for us to move on to thinking a little bit about the idea of HD maps and how HD maps play in the concept of localization, and then hopefully move on to data sharing among the fleets. So, what is the purpose of an HD map, and how useful are they currently? And I don't know who wants to take on that question, but anyone can weigh in.
Yeah, Jimmy, maybe I can take a shot at it. Since we have, in the recent years, we've announced our partnership with HERE, where they provided the HD maps, and they've hosted their licensed SDK application on our MEC, on the wavelength zones that we have. HD maps, similar to the two-dimensional maps that we're used to, they provide a more detailed view for autonomous vehicle. So as humans, we are used to those two-dimensional maps, and the HD maps there are different layers. There's static layers, and then there are dynamic layers on top of that. So while certain things do not change on the road, for instance, the road signs, the lane marking, generally they wouldn't change in the near term. But then there is more transitional and dynamic data that changes at a very rapid pace. For example, in a city environment, there could be pedestrians walking in an urban environment, for instance. So how do you add that dynamic information and share with the other road users and create that situational awareness? And while the sensors on board the vehicles can see line of sight, what we really demonstrated partnering with HERE was how do we provide dynamic HD map updates, and to avoid collisions, to give VRU alerts, which is vulnerable road users like pedestrians and bicyclists. So there is a static layer, which doesn't change regularly, but then there's a dynamic layer. And this really adds a rich set of data that the autonomous vehicles can leverage. And especially those dynamic updates, they leverage the cellular connectivity as well as the multi-access edge compute and the precise location capabilities, all provided in sub tens of milliseconds or 20 milliseconds. The capabilities that 5G augmented by edge computing offers in a more geo-fenced way, or in a more geographical, confined location.
So there's two things that I think I want to try and touch on based on what you've just said, actually. And the first is, how easy is it for a vehicle to work out on the fly what counts as an important or like interesting dynamic change compared to what it sees on a map? So if it's just a pedestrian in a slightly strange spot, that's one thing. If it's roadworks that have suddenly appeared, that's another. But what are the kind of like edge cases, and how do you write software or develop software that can do that really quickly?
Maybe I
know who
can
wants to
start
go.
with that since we have a full stack at Zoox that does exactly that. So it's important to separate out what Jyoti was saying as far as the static information. That's typically encoded in an HD map. And then there's semantic information like lane marking, traffic light locations, and other things that can assist the AV to give meaning to what it's seeing. But mostly HD maps are about static information. Dynamic information, such as pedestrians, vehicles, all of that is computed on the vehicle with what's called the perception module, typically. And that's essentially, you can think of it, the pipeline, roughly speaking, is the vehicle at every tick figures out where am I with respect to the static map, and then what are all the things around me that are dynamic, that are essentially, you can think of them as being embedded now in the map, kind of like a video game, really, and trying to give semantic meaning to what those things are. Is this a pedestrian? Is this a vehicle? Is it a bicyclist? And so on. Those modules obviously tightly work with each other. The localization module tells you where it is. The perception module then says, with respect to where I am, this is where all the entities are. But we also use AI technologies to say things like, where are these entities headed? So that's called prediction. And then the final piece is planning, which allows you to say, okay, should I continue driving forward? Should I start slowing down? Should I change lanes? And so on. And so in that world, the perception module is doing a lot of the heavy lifting of what is going on in the scene. And that by definition is dynamically computed. It is real time. And there's nothing particularly, you can do a lot of priors, like the mapping information to help out the perception module. But at the end of the day, the critical path is the perception module to have a very high degree of fidelity.
And if a vehicle sees something that it thinks is actually a change to the map, so maybe it sees that a traffic signal has moved, or maybe I don't know. You guys might have better idea, examples than I do.
A building could be demolished, for example.
I mean, that is an extreme but a good example.
Or modified. Often there is construction on a building and it puts up, like they put up scaffolding. We have encountered that where the scaffolding will create a geometric variation. And if you're using, for example, a LiDAR-based pre-mapped HD map, that could significantly move certain surfaces by like a meter or two. Sure. But the nice thing is, I think Christoph mentioned this, there's interestingly, in dense urban areas, the amount of information that's available is so rich because of the variation that you can, the mapping technologies, the localization technologies have built into them lots of sort of redundancy, but implicitly. And so you can use that to detect when there are these deltas. And that can be, at Zoox, we have developed a pretty robust methodology that allows us to detect when there's uncertainty in the system to begin with.
Okay.
So Ashu, I'll add here, and Jamie, it's good for one autonomous vehicle to see what's in their surrounding. For example, a slippery road, a hazard that they detect. But the power of this cooperative maneuvering and an intelligent transportation system is really sharing that data with the other users on the road. So if you are detecting a hazard and I'm driving a mile away, can I get that notification and I can reroute my vehicle to a different route because I can avoid that situation. So having that situational awareness is one thing key for the autonomous vehicles themselves, but sharing it with the rest of the world, more crowdsourced option is really where the magic lies.
I have lots of questions about this bit, actually. So my first one is, how much of that data do you want to share? Because there's a virtually unlimited amount of data that you could share across a fleet, and 5G data connections aren't free. So what do you share? How do you choose what to share? What's important, what isn't?
Yep. Yeah, Jamie, that's an excellent question. And we hear that from our customers all the time. There is a very concerted effort that these autonomous vehicles are generating terabytes of data, in future exabytes of data. All that data, you need to find that needle in the haystack and really find out what's the essential data. As I said, the data might get stale. So we need to know locally in this location at this time, what's the relevant data, and extract that data, filtered, annotate, extracted data that you share with the application that's on the edge computing, or data that you need to process quickly and share with the other vehicles. So there is this smart data concept that is industry-wide gaining traction, that don't just upload big data and upload everything, which is cost prohibitive and that is just meaningless, but intelligently upload data that is relevant for the applications that are using it. And a good example of what here said, their partnership with Lyft of ride sharing, just send that relevant data of exact precise positioning and integrate it into Lyft application. Now, when I'm standing on a New York City intersection, my Lyft will know exactly where I'm standing with precise position of the Lyft vehicle as well as the user that's going to ride share. You've got that exact location. So all you need is that specific data set. You don't need the whole lot of information to be uploaded.
And so with all this data flying through the air, is there any benefit to processing that as it flies between different locations? Is like, I suppose this is a conversation about processing on the edge versus in the car. Does it ever make sense to process information on the edge, or is stuff happening just well, I'm sure you would say that, Jyoti.
No, I mean, I would just add here that it's not this or this. We had the device edge and then we have the cloud, but now there's a new edge emerging in between, which is multi-access edge computing. So we look at it as an OR gate, where you would distribute your workloads across the the edges, the vehicle edge or the multi-access edge compute or the cloud. It's not one or the other. It's not that solution. And we see the application providers are distributing their workloads. If it's a latency critical workload, you move it closer to where the user is. It could be the vehicle edge that makes the most sense. And then you will host it on the vehicle. But if you're able to offload some of that compute and save in terms of battery efficiency, in terms of compute memory requirements of your vehicle, then it makes sense to leverage the power of 5G and MEC and offload some of that compute that you don't need on the vehicle. So there are fine trade-offs that the industry together, and that's where these partnerships and discussions are key to success in this area, because we need to work out how do we distribute these workloads.
So that sounds like the start of a conversation for everyone else as well. What does make sense to do on the edge versus on the car? Maybe Christoph or Alejandro.
I mean, ultimately, I think everything that is safety critical, that figures out what the car is supposed to do, whether to brake or not, with low latency, obviously needs to be done on the vehicle. When it comes to things like detecting changes in the map and creating those snippets that are needed to update the map, then there actually is a trade-off, right? Some things you need to do on the vehicle to really reduce the data rate, data size. You can't just upload all the point clouds. Even with 5G, that won't work. So there's a tremendous amount of work and data reduction ultimately that needs to happen on the vehicle, and there it's really interesting and important to really figure out what is the change, what do I need to model it, which kind of data do I need to send to my backend to actually enable the backends to create an update, a patch, a fix, an improvement for the map change at that point. And I mean, the static information in the map is still extremely precise information, right? Very, very detailed information that requires high fidelity, high precision sensors when it's being created. If you were to update it with information from sensors or that are low resolution, low fidelity, the map would be more up to date, but it would get worse in terms of quality. Right, so you need to your sensing system, the one that you use for crowd updates, needs to be at least as good as the system that you use to create the map, in order to preserve the accuracy of everything. So it's a very thin line and fine trade-off between everything to make it work holistically, and it actually is very different for robotaxis as well as for let's say level 2 to plus applications, right? Because you just have very different requirements. So it is a case-by-case determination, that's for sure.
So I have a couple of questions about that as well. And I guess my first is there any value in trying to create like hybrid maps that do sometimes use data from lower fidelity sensors, or is that just an impossibility?
No, it's definitely possible and actually even necessary, right? Because you can create your base map with everything, with all the road geometries and everything based on a very precise sensor, but then you also need to detect and detect changes and include traffic signs and traffic lights and things like that in there. You need different sensing modalities to do that. You need the camera to do that, for example. You definitely won't be able to do it with the LiDAR anytime soon. And then there are many other things that maybe you can detect better with the radar that you want to leverage. There are approaches to do something like a radar signature, for example, as a localization layer as well, and use that. So for that, you would use a radar, which is definitely a lower fidelity sensor in terms of geometry and contour measurements, for example, than a 3D point cloud generating sensor. So you really do integrate all of the different sensing modalities in it, and everyone contributes a little bit to the entire big picture. That's for sure.
Okay, which actually brings me to my next question based on what you just said, which is if everybody's contributing to the same big picture, we have all kinds of different cars floating around on the road, aren't they all sending different kinds of data? And how do we deal with that situation?
I can maybe add some perspective, Jamie, here. So one of the key requirements for this kind of scenario from automotive customers and more traditional ones, as well as the AV providers, is a multi-MNO, multi-OEM scenario that they do want to tackle. That I don't know what's the car ahead of me, what's the car behind me. I don't know which network they're on, whether they're on one operator versus the other operator. So they want these kind of interoperable solutions. And that's why we have standard bodies. So whether it's the third generation partnership project for the 5G or 4G cellular networks, or there is ETSI, which is defining some of the MEC standards, there are standard bodies and a lot of testing that's going on, interoperability testing going on between onboard unit providers and connectivity providers. So there's definitely going to be that aspect where these interoperations will have to take place, and there are standards that people need to adopt, as well as regulatory landscape. We have to keep that in mind because a lot of this will also be enabled by the regulations.
I think this goes back. Sorry, can you hear me? Sorry,
yeah, go for it, Ashu. Go for it.
I was just going to add that. I mean, what Christoph said is important, right? The use case does matter. But the use case is a robotaxi use case, such as Zoox is working on. We cannot rely on anything outside the system, so to speak, right? In other words, if anything is safety critical, that needs to be a very low probability event that can happen. And the long tail is very important here, right? So for example, signals like even with 5G in tunnels or in urban valleys, as they're called, with big skyscrapers, if you have a dropout, even for a few seconds, any safety critical system that is reliant on those signals will have a challenge. And if that happens and now multiply that low probability event, but with thousands, tens of thousands of vehicles all around in many cities, and you start seeing that those are actually non-trivial occurrences in terms of frequency. And so it's very important to devise a system in that way, where all of these additive technologies enhance the performance of the system without necessarily being required for the system to operate when they're not available. And that's the balance I think everybody's going to have to figure out as we go along this year.
Yeah, I absolutely agree, Ashu. And these are complementary. In fact, V2X I would consider as an additional sensor to the sensors you have on board your robotaxis. So we're not saying that this is going to replace what you have on board, but this is an additional sensor that you can leverage in addition to what you already have.
Christoph, I think you were about to say something as well.
Yeah, I just wanted to take a comparison to other industries. I mean, aviation industry is a pretty good kind of role model for a lot of things that need to happen in robotaxis, and the approach there is exactly the same, right? All of the safety critical signals are actually transmitted via wires, not just one, but maybe even two in some cases, and then step by step people try to add more and more wireless transmission in there, but usually really for low like QM signals, right? Things that are not safety critical, things that where it maybe doesn't matter that much if they get lost once in a while, to just support other use cases rather than the actual flying. And I think it's going to be very similar for robotaxis and as well as actually for level 2 systems, because whenever you have something that is safety critical, you just can't risk that low probability event that might happen at some point in time, and then something bad happens. So it's really a complementary addition, not necessarily something that you do for something that is really safety critical and needs to happen on board.
Yeah, I think that's a really great point. Thanks, Christoph. Sorry that my internet connection occasionally keeps cutting out, by the way. I hope it's not too distracting. I thought we could start bringing things together, as soon as we're getting towards the end of the event. And I wanted to kind of speak a little bit about what big challenges there are left for these localization issues, and how solving them is going to get both kind of like robotaxi use cases and the level 2 use cases actually working. Can you actually see me? Okay, so if anybody can hear me, then my question really, if everybody can hear me, I guess my last question to try and wrap things up is, how important is the kind of like what are the big problems left in solving localization, and how important is solving those to kind of like getting more and better autonomous vehicles on the roads?
So maybe I try an answer. So I think that the localization and the cloud HD map, right, is one probably of the most powerful sensors that we have in the car or in the system. Why? Because it aggregates a lot of information seen by many other sensors over time. It can look much further. It can look around corners for static objects. So that will be a very important source of information. I think, as we said, a car, doesn't matter if it's a robotaxi or a consumer car, has to be safe. So it will always be and remain something that comes on top and will not replace what is available in the car. So we will have a hybrid system design in the future. I think with 5G and also with our edge computing capabilities, what will happen is we will make the cloud part grow. Why? Because we have more edge computing, because it is we have low latencies, we have a bigger bandwidth, and probably we'll also have standards so we can share data over different providers and so on. So this part will grow, but it will remain a challenge to balance both parts because we have to improve both sides so we can design a reliable and a solid system that at the end will have to drive a car as safe or safer than a human driver. And that's a lot to be accomplished. And the challenge that comes with that is at the end also, how do we prove that the car is safer than a human driver, right? And I think also that the clouds, shadowing, sharing data will also play a big part in answering this question.
Okay, thanks, Alejandro. Sorry about the technical difficulties at my end. So I think now might be a great moment to wrap up this conversation. So thank you for that final answer, Alejandro, and thank you, Ashu, Christoph, and Jyoti for being part of this conversation. Thank you to all the viewers out there who've been joining us, and I hope we'll see you all again really soon. I hope you enjoyed this conversation. I certainly thought it was incredibly interesting. So thank you very much, everybody. Thank you. Bye-bye.